Coming up on Air Force Space Today, we profile the efforts to reduce launch costs. The United States successfully brings down an ailing satellite. We take you behind the scenes of launch operations on the East Coast. And we introduce you to an Air Force doctor who moonlights for NASA on this edition of Air Force Space Today.
Main engine ignition, 4, 3...
Space Shuttle Atlantis launches from Kennedy Space Center.
0 and liftoff of Space Shuttle Atlantis as Columbus sets sail on a voyage of science to the space station. Houston now controlling.
It's a great honor to be selected to be part of any mission, and especially a part of the Space Shuttle program. It's a way for me to be involved with the space program, which was a dream of mine for many years.
Roger, roll, Atlantis.
Columbus weighs anchor from its port in Florida. Atlantis on the proper alignment, heads down, wings level for the 8.5-minute ride to orbit, taking aim on the International Space Station.
Well, it was in 1991 when I started as a flight surgeon. I worked for Special Operations. Specifically, I was the flight surgeon for the 55th Special Operations Command at Hurlburt Field.
See, you're doing great.
And then after that, I subspecialized in ear, nose, and throat, and after that, I finished up my time in the Air Force on active duty and joined up with the reserves. During that time, I transitioned to being a part-time flight surgeon and was lucky enough to be selected for being part of the space program. For every 2 astronauts, there is 1 Pavehawk that has a doctor on the back of it, as well as 2 pararescuemen. So for today's scenario, there were 8 Space Shuttle astronauts, and so there were 4 helicopters, 4 doctors, and 8 pararescuemen. What the mission is to support the Space Shuttle astronauts in case something were to go wrong, either during a launch if they were going to have to return to the launch site, or they were going to have to abort and go once around the Earth and come back, or during a landing. They only get 1 shot because they're coming through without power. They're coming down as a glider. And so if anything goes wrong during the landing, they may end up in the Everglades, they may end up in the ocean, and if that's the case, then we are there to rescue them. Some of the thoughts would entail what kind of scenarios might I have to be taking care of here over the next few hours? What kind of injuries might the astronauts have in a given scenario? You know, like today, we were worried about poor weather, and so I'd be worried about exposure type things, as well as exposure to all of the toxins and toxic things that are on the space shuttle that could affect the patient. I'm also thinking about how I can best support the pararescuemen that are here with us as well, because they're going to be the first line of defense when somebody is downed and we can't get to them readily. They're going to be dropped into the area first and try to get the patient stabilized. The airframe that we use is the HH-60 Pavehawk. A Pavehawk is a very close cousin to the Black Hawk, which is used by many other services, including the Army. The real difference is the capabilities that it has, including increased avionics. It has increased GPS capabilities. It has the ability to fly in low terrain, in basically no light scenarios, in bad weather, and it also has the capability of refueling, which is an incredible experience to watch. To be able to see a helicopter joining up within about 30 feet of a flying C-130 and to be able to get fuel on the fly and then be able to continue its mission is an absolutely amazing thing to watch. I tell you, this has got to be one of the most incredible experiences in the world, to get to be a part of the space program and to really feel like you're making a difference. The astronauts really wouldn't be able to go up without all of the support personnel that it takes. So I find this mission to be a great honor, and it's absolutely one of the most incredible experiences that I could have ever imagined.
The 45th Launch Support Squadron at Patrick Air Force Base is the flight line for Department of Defense spacecraft.
The LCSS team oversees spacecraft hardware arrival, processing, testing, and launch through direct delegation from spacecraft development wings throughout the DoD, ultimately providing launch-based mission assurance for space.
And the primary purpose we have at the 45th Launch Group is mission assurance. And what that is not only being there when the hardware is being processed, but doing risk assessments, ensuring that that hardware comes together properly and that it's going to work on orbit.
That's basically our job. We do all the processing to assure mission assurance of all the spacecraft that come through.
And mission assurance is a very unique thing. In the aircraft world, you know, it's fly, fix, fly. If there's a problem, you bring the plane back, you fix it. But with spacecraft, you only get 1 shot. And through technical expertise and maintenance backgrounds, we provide a level of confidence to our leadership in making sure the taxpayer dollars and go to equipping our warfighter with greater capabilities.
So when it all boils down to it, making sure that the hardware works the way it's supposed to when it gets on orbit to provide capability to the warfighter.
Our job is not even, I would say it's not even defined. Our job is whatever it happens to be that day. Our job is to making sure there's no FOD left on the floor. It's everything that's not covered. So when we talk about a little piece of wire that didn't get completely cut off, that can be failure of the billion-dollar asset that is a GPS satellite. So our job doesn't stop and end when they stop and end. Our job is to ensure on every level mission assurance. That's what our job is, and it's redefined every single day.
A lot of people, like including myself, we're willing to put in the hours and this and that to get it to that warfighter, and it's you could tell. You just walk around, you could tell that these people that are here, whether they're civilian, officer, enlisted, that they're very happy and proud of what they do, and they're dedicated, and they're going to do it to the fullest, which we do every day.
It is a true team effort here. On the GPS world, I lived with a contractor, the Air Force, Aerospace, some of the CETAs that support the programs. We co-located in one facility, and we became a true team.
I would say that this squadron, with the mission assurance role that we offer to the Air Force, is just critical. Without that, I don't know, there's no other way of guaranteeing that those satellites are going to operate on orbit.
A very rewarding feeling working with people that really know their job, that are very passionate about being here, and that love providing this for the Air Force.
I've been down here for 12 years, and I was up in Pennsylvania when we built the satellite back in the early 90s. And I followed it all the way down here then.
We see, this is the spacecraft flight line, so we're able to provide missile warning launches here and then transition to launching basically a position, navigation, and timing and targeting. So we're going to launch another WGS here in the spring and then transition to AEHF and other systems. So to be able to see these systems and work with them as they arrive from kind of a critical point from arrival to launch, and all the processing and testing that needs to go to get them up in orbit. We're just fortunate. I'm fortunate to have a great group of officers, NCOs, civilians, and really people that work for SMC and also for Air Force Space Command and through the 45th Space Wing up to the 14th Air Force. So really multiple teams, multiple customers, but really one common purpose.
Making sure that the hardware works the way it's supposed to when it gets on orbit to provide capability to the warfighter.
Providing a total mission success. So that's our goal.
President Bush authorized a first-of-its-kind attempt for the United States using a missile to bring down an ailing National Reconnaissance Office satellite because of a potential danger from its hydrazine rocket fuel.
The projectile, a modified Navy missile, Standard Missile 3, was fired from a Navy ship and successfully intercepted the NRO satellite just before its decaying orbit would have brought it back into Earth's atmosphere.
Now, some say this effort is an answer to China's successful shoot-down last year of one of its own weather satellites.
U.S. officials insist this decision was based solely on safety concerns.
Performing a vital and significant role in national defense, the U.S. Missile Defense Agency, along with Air Force Space Command, the Army and Navy, as well as Japan's self-defense forces, are working to implement a complex missile defense multi-layer shield that includes satellites, ground stations, ship and ground-launched missiles, and airborne lasers.
Playing an integral part of the anti-ballistic missile defense shield are the Defense Support Program satellites, known as DSP. Originally placed into geosynchronous orbit by the U.S. Air Force on Titan IV rockets, DSP provides continuous global surveillance and early warning of launches and the tracking of potential threat missiles. Since its inception and deployment in the early 1970s, DSP has provided uninterrupted space-based early warning capabilities. Its true effectiveness was proven during Operation Desert Storm in 1991, when DSP satellites detected the launches of Iraqi Scud missiles, providing warnings to civilian populations and coalition military forces in the region. With the changing security balance in Asia, the Missile Defense Agency is erecting the world's most complex ballistic missile defense shield in cooperation with the U.S. Armed Forces, along with the nation of Japan. With advanced improvements, DSP has increased ability to provide accurate, uninterrupted service in detecting missile or spacecraft launches, and, if they occurred, nuclear explosions. processing and providing information on missile localization, situation, trajectory, and target projection. While DSP is one of the key components of the anti-ballistic missile shield, it is only one link in establishing a credible warning and response network. Another vital element are the Joint Tactical Ground Stations, known as JTAGs. JTAGs are transportable information processing systems, some located in Japan and manned jointly by the U.S. Army and the Japanese military. These mobile units receive and process in-theater raw wideband infrared data downlinked from DSP sensors. One of these JTAGs can process data from up to 3 DSP infrared missile warning satellites, determining launch points and time, azimuth of flight, and predicted point and time of impact for theater ballistic missiles. The third portion of the anti-ballistic missile system is the response phase, which involves the interception and destruction of threat missiles. This includes the U.S. Navy's Aegis missile and the Army's Patriot PAC-3, an improved version of the Patriot anti-missile system, which achieved fame during the 1991 Gulf War, and finally, the Air Force's airborne laser, flown on a modified Boeing 747. To continue the maximum in performance and operation of the JTAGs and the anti-ballistic missile shield, Air Force Space Command is planning for the deployment of a new constellation of space-based infrared system, or SBIRS satellites, which are scheduled to replace the current DSP satellite, thus assuring that this defense system of command, control, and combat management will provide optimum fulfillment of its mission for today and tomorrow.
The United States is ever trying to develop more and more satellites at a lower cost.
This would benefit both the Air Force and NASA because critical satellites could be replaced more easily if damaged.
Now, this effort doesn't just involve large aerospace giants, but also comes from small, entrepreneurial companies.
These lower-cost launches could also encourage increased educational, commercial, and scientific uses of space that are not being pursued because of the expense. Not counting the cost of a satellite, most space launches now cost from $30 to $100 million. But companies such as Orbital Sciences, SpaceX, and Microcosm aim to reduce these costs to between $5 and $12 million. Microcosm was founded in 1984 to conduct research for the Air Force and to specialize in reducing the cost of space missions. In one of their projects, the company is working under contract with the Air Force to develop a rocket that can put a satellite in orbit with 8 hours' notice and costs under $5 million. Part of their cost-cutting involves the use of a simplified rocket engine and lightweight composite propellant tanks. Another company in pursuit of low-cost rocketry is Space Exploration Technologies, or SpaceX. They are building an array of rockets, ranging from a low-price Falcon 1 for light satellite payloads to the Falcon 9, which the company hopes will be able to deliver cargo to the International Space Station. SpaceX claims they will be able to launch a payload for 1/2 to 1/3 the price of larger competitors. The approach of Orbital Sciences Corporation takes recycling to a new level. Their Minotaur 1 launch vehicle uses parts of government surplus Minuteman II ICBMs as the first and second stages, and an adaptation of their aircraft-launched Pegasus rocket for the third and fourth stages. This vehicle put 2 Air Force satellites in orbit for an average cost of $11.5 million each. Their proposed Minotaur 4 will use surplus Peacekeeper ICBMs for the first 3 stages and a section of the Pegasus for Stage 4. Orbital is under contract with the Air Force Space and Missile Systems Center to develop and operate this low-cost vehicle to launch satellites into low Earth orbit. The efforts of these companies and other entrepreneurs are crucial in keeping the U.S. in the forefront as Russia, Europe, and increasingly China become more adept in space technology.
For over 34 years, he worked behind the scenes, gaining valuable experience in every program office at the Space and Missile Systems Center.
Mr. William Mikish, Executive Director of SMC, started out as a junior civilian and spent his entire career at Los Angeles Air Force Base.
Over the years, he went from an eager GS-5 recruit to a general equivalent senior executive civilian.
Mikish's name became synonymous with space acquisition, and as he retires, we remember his legacy.
Air Force Space Today concludes our two-part series on a legend in the space business, Mr. Bill Mikish.
Mikish's time-tested experience and keen management skills led to his being chosen for the Senior Executive Service and promotion to Executive Director of SMC in 1994.
Well, clearly, Bill is dedicated to SMC and to SMC's mission, to national security space.
Clearly, Bill, his tenure here and his leadership over now some 34 plus years is simply unrivaled.
You know, there's not a lot of people around today that have the breadth and experience that Bill Mikish has. 34 years in one assignment at Space and Missile Systems Center. And if you look back across all that has happened in that period of time in space, he is by far the most experienced, most qualified expert in the business, particularly in space acquisition.
Clearly, Bill's accumulated experience from those 34 years is going to be irreplaceable.
Mr. Mikish is a walking encyclopedia. I mean, he knows everything about every program on this base.
I think there's almost nothing he doesn't know about the whole space enterprise, that he has so much to offer the entire center, and he probably has forgotten or will forget more than any of us will know about space.
The crowning achievement for Bill Mikish was the implementation of the Systems Acquisition Management Support Complex, better known as SAMS, in which the old Area A was exchanged in a land swap. Through SAMS, SMC was able to build all new consolidated facilities.
Where we are today is a direct result of Bill's vision, his tenacity, the land swap commercial real estate arrangement that led to the transfer of Area A properties for the creation of the new, what is now the Schreiber Space Complex, was as a direct result of Bill's vision and his hard work pushing through what seemed like impossible odds to get agreement between state, local, federal authorities, companies, and banking and other financing individuals to be able to make this wonderful complex a reality.
We came up a little bit short on money in the very end. We worked through that. We had 9/11. We had to change a lot of the configuration. When we had some of the environmental issues, the environmental folks here in the state kind of said, well, why don't you come back in 6 months and we'll start to look at it, then maybe in a year we'll start to run the models. And we said, you guys got some time tomorrow? And they looked at us like we were from Mars. We called Mrs. Harmon, and Mrs. Harmon, they were out there on the curb waiting for us the next day. There was a lot of those things where we had some folks moved heaven and earth to make it happen. So it's one of the most gratifying activities of my career here to see that whole thing pulled off.
Mr. Mikish is a dedicated husband and father to his wife Kathy and 2 children, Stephanie and Krista.
The best part of Bill Mikish is Kathy Mikish.
We both went to the same Catholic high school, and the year we were seniors, they decided that they could have boys and girls in the same classroom and we would be able to control ourselves. He and I took honors English, and he sat behind me, and he and Pat Rothstein used to tell really good jokes. So I kept leaning back to hear the punchline on the jokes, and that's how we met. My girls have always gone to visit him on, we call it the 6th floor, and now it's the 4th floor, but we still call it the 6th floor. And since Stephanie was tiny, every time she'd come in his office, she'd sit herself down at his desk and write him a note. And the notes evolved over the years. The grammar got better and everything, but it was things like, be nice to your secretary because she has candy, and things like this. And so when he cleaned out his desk here a couple weeks ago, I saw that he had kept every single one of those notes. And, you know, I'll always remember that.
Mikish officially retired from the Senior Executive Service in January 2008 after spending his entire 34-year Air Force career at the Space and Missile Systems Center.
Well, I'd like to thank him. I don't think anyone will ever be able to replace him.
Invariably, as a tough issue came up, the decision was, let's send Mike Ish.
He'll leave a big pair of shoes to fill, for sure.
I would just like to say that I've learned a lot from him, that he is a tremendous leader, and I hope to emulate him as much as possible throughout my career.
I think many people will remember Bill as somebody who understands how the business operates. He really knows SMC inside and out.
I would say that I am personally and professionally indebted to Bill to have had so many wonderful opportunities to work together. I truly consider him one of my great friends and colleagues in the space business, and it is something I have a great deal of pride in, and I hope Bill shares that likewise.
There are many, many of us who count ourselves privileged to have worked the Mike Ish era.
William Mike Ish. His contribution to space and the defense of the nation places him among the legends.
And that'll do it for Air Force Space Today.
Thanks for watching.